Hey, how it's going, guys? In this video, we are going to look at the design patterns behind orchestration of AI agents. So if you are building agentic AI or AI agents or multi-AI agent system, you would have heard about this term called orchestration. And there are orchestration frameworks that we use. But there are different design patterns, behind this orchestration also. So if you look at here on my screen, we have different, and there are 5 orchestration patterns that we have, starting from sequential orchestration. Then we have MapReduce orchestration, we have consensus orchestration, we have hierarchical orchestration, and then producer and reviewer. Now, orchestration becomes a core technical capability when you are building, in the agentic AI space. Simply having powerful agents is not enough. The key lies in enabling them to collaborate effectively, right? Because when you're building multi-agent systems, there are multiple agents, but how do they collaborate with each other is something the key here, right? Now, this is one of the most critical skills, I will say, to have it when it comes to this technology, because it's not different than what HDEs do, right? Software development engineers. If you look at the interviews of HDEs, a lot of product companies, they ask questions mainly from data structures and algorithms and HLDs and LLDs, like system designs. It's very similar for AI also, right? You should know how to design a robust and a scalable AI system. It's not that, okay, you took LangChain and you build a POC and it's okay, I have built a multi-agent system. I mean, that is fine, but there is no value out of it. That's why the companies like Gartner and McKinsey's of the world, these big four or whatever these companies, they are saying that AI agents projects are failing. McKinsey says 95 or 99% of them failed. There is no value. 40% of them will be closed by 2027, so on and so forth. So keep this in mind. You should have this orchestration skill sets to how to build it the right way. And that's what we're going to look at here is basically, designing the communication protocols, the workflows, and the decision making mechanism between agents and enabling the entire system that you have to handle failures, works collaboratively and accomplish complex tasks, right? That's the agenda of this video, to show you how you can build multi-agent orchestration playground. So now, if you look at here, I will give you the code also. This is a playground that I have created, and this is not the first playground. Before this video on the channel, we have memory playground for AI agents, chunking playground, RAG playground, retrievers basically, and now we are building multi-agent orchestration playground. And we'll build more playgrounds because the playgrounds are very important for people to kind of immediately try it out and go through the logics and understand it, and then they can implement it through the code. Because code will anyway it will be available on my GitHub repository. You can just go and get it. So if you look at here, this is the code. This is how the code looks like. Now we have very modular code base here. If you look at the patterns, it has 5 different orchestration techniques or the design patterns for orchestration. And you will get that because these are very modular. If you are building something, you can use that in your own applications also. Now I'll first show you how it works. Let's say, and you have to enter your API keys, guys. That's how I built it. I built it very modular way. I don't want to take any responsibility when I deploy this, right? You just enter the key and it will work. So here I have given my API keys of OpenAI, and you can select here all the orchestration thingy. Whatever is selected, you can find out some topics here. You can see this is healthcare topics that I have taken. Basically topic for the report generation pipeline. It generates the report. Let's try it out, the sequential orchestration demo, and I'll come back here. The moment you do it, you can see the agents are working. There are different agents. So we have sequential orchestration demo started, report generation pipeline. We have data collector, we have data formatter, we have data analyst. So there are different types of agent that are working right now. So I'm going to of course show you that, but let's first complete it. Then we're going to go into a little bit of theory also to understand that. And this is how I create my video, guys, right? I want to kind of create these videos, not only building N10 workflows that anybody can do it. And if you want to get that, you get your N10 workflow templates here. There are more than 200 agents now. This will be updated by the end of the week. You'll have 200 plus N10 workflows that you can get it. And this every week we're pushing new agents workflows into this. So you can get it. I'll give the link in description. Now you can see here, when I ask this sequential orchestration demo, execution is completed successfully. It gives you the execution time, total tokens, how much tokens it took, success rate, and how many agents were used actually. And it gives you the execution timeline also that you see, result visualization for all these agents that you see. How much time which agent took, because this will help you in the ops part, and you can use libraries like Agent Ops or Pika or Phoenix by Arizi, Galileo AI, and thousand other tools like that. That's up to you what you want to use. Now, if you look at detailed result, here you can get it the results here. AI in healthcare business report. You find out the summary. You find out the analysis from the agents. And it basically the idea task here was to generate a healthcare report. That AI in healthcare report, and five agents kind of used it together, and they got it here. You can see data collector, data formatter, data analyst, content optimizer, and report finalizer. So they all came together and they do it. Now let's come back, because this is not the most important thing. I want to show you here what we are doing, right? That's the most important thing. So I'm going to write here for you. So let me just write it. So I'm writing here sequential is our first. So I'm going to write sequential orchestration, because this is important, guys, for you to learn it. Don't only kind of goes on the hype thingy. Hype is good, but you should, if you want to crack some good companies interview, you have to kind of understand this thing. Or if you are building some, you know, if you are building some good products, you have to do it. So in the, what happens here is you will have an input trigger, right? You will have an input trigger. So I'm just writing here input or a trigger here. And this input trigger will have multiple agents. So let's say I have agent A. This is agent A. We'll have agent B. It will happen in the sequential thing. Agent B and dot dot dot. We'll have an agent. I'm writing agent N, and then you'll have your final output. So here I'm writing final output. Now, what happens in this is the most intuitive way to kind of collaborate. Like Crew AI kind of uses this by default, where you have sequential. Now, the agent performs tasks sequentially, in a fixed order. So if you look at the order here, right, this is a fixed order that we have. This is completely going like this direction, which is in a fixed order. So you have to keep in mind. Okay. Now, what happened here is, now the output of one agent, so output of this becomes input of the agent B. So this is my output here, right? Now this becomes an input, and same follows, in this fixed order. So it's pretty simple. Like a data collection agent will acquire the raw information from, like, some data repositories or open internet or wherever, and then that will give the information to the next agent, in the pipeline. So the pipeline processing that we have. So if you look at here on the multi-agent orchestration, we have data collector, then you have data formatter, because when you collect data, that will be in the raw format, like, you having URLs, HTTP URLs, and you'll have images, formats, text, bullet list. You'll have your own formatting style that will go into the data formatter part. So if you look at here, the data formatter, then we'll have the data analyst that will analyze the data, and then we'll have content optimizer, and then report finalizer, and so on and so forth. So this is how the sequential kind of works. Now, the advantages of this design pattern, is very clear logic and simple debugging, but the flexibility is a limited. There is no flexibility. So the pros and cons are there. So if you write the pros, so let's just come back here on our tab here, right? So if you write here the pros here, the pros is simple, that it's, of course, it's simple to understand, and the latency is also fine, okay, because it's simple, clear logic. So I'm going to write clear logic, simple and easy debugging, right? This is how we see that easy debugging. But the cons are also there. So there are cons also. So if we talk about the cons, now cons are also very clear. It's very limited. No flexibility, I will say. Very less flexibility, between the agents. So less flexibility is there. Any error in any link will affect the entire process, because it's in fixed order. You have to take the output. Let's say there is an error here. So let's say there is an error here, right? You find an error here, right? Now, if there is an error and if you don't have any good fallback mechanism, this entire process will fail. So this is the problem here in the sequential orchestration. So that's why, it's one of the most simplest and easiest way to build. Like Crew AI do it for default, right? I said Crew AI, and I think other agents also they have for default. So you can try it out testing them. So this is on the sequential. Let's move to the MapReduce actually. Now MapReduce, we have two different types of demo here: summarization and sentiment. So let's say summarization is selected, and it also gives you the execution history on the playground. So if you look at the map reduce orchestration, I'll just come here. It says parallel computing intelligence breaks large tasks into independent chunks, processes them in parallel, and then combines results. Excellent for scalability, right? So this keep this in mind. This is very good actually. And document summarization. When you want to summarize things, map reduce is one of the best actually. Okay. So let's just come here in the map reduce. Okay. So I'm just writing here map reduce. So let me just write MapReduce actually. So MapReduce. Now MapReduce, we'll discuss about it and then we'll go back here on our tab. Now summarization is one of the most important use case when it comes to MapReduce. Also, let's say we have an input task on here. Okay, I'll just take the same color. I want to follow on the same color. Now let's say here we have an input task. Here is our input task. Now input task will have, let's say, these agents. So let's say I created an agent 1 and I'm writing A1, and then we'll have an A2, and then we'll have an A3. So A1, A2, and A3. Okay, these are our agent. Okay, that you have. We'll have, and then we'll have reducer here that will reduce. That's called, so it's in map format, right? And then what we're gonna do, we're gonna have a reducer. So this reducer is important. You know, if you would have seen this in LangChain RAG also when you are building the retrieval chains, right? You'll have map reduce there also. So reducer, and then it gives the result. So this reducer is the key actually here, you know, in this process that you see. So basically the model draws on the principles of distributed computing. So if you have understood distributed computing, that basically breaks the large tasks into multiple independent subtasks, right? So what happens, you know, this basically, let's say there is a task, input tasks. Now these tasks will be divided into 1, 2, 3 different subtasks, and then they will be performed, like it will be performed independently, and then they will significantly, you know, this basically significantly improves the efficiency through this parallel processing. So this is a very cool concept actually. Now a key requirement is that subtasks must maintain independence, like there is a correlation or dependencies, like when you do it in the knowledge graph and things, that's where it breaks. Okay, so in large scale text processing scenarios, the system divides a document, that let's say that we have a document collection into independent segments, and each summarization agent performs summarization on each of these documents, right? And then collectively creates a final output, global summary. So summary, always remember summary. Let's say you have, let's say this is the one document. So doc 1, you have doc 2, you have doc 3. Now what will happen is there will be a summary of this. So this becomes summary 1, this becomes summary 2, and this becomes summary 3, and collectively you get a final summary, which is a global summary. I'm talking from a use case standpoint, so you understand map reduce part. So this is how the map reduce works. So if you look at the map reduce, okay, we're gonna run the map reduce. You can see it says breaking large tasks. Let's come back here and understand. So you can see it says starting map phase with 6 chunk. Map reduce has been started. Okay, created 6 chunks. So there are different chunks for summarizer. Summarizer 1, summarizer 2, summarizer 3, summarizer 1, summarizer 2, so on and so forth. Right? And starting reduce phase with 6 result. And it gives you the results. So that's how it works. So it works good. And you can see the output also. Execution summary. Let's come back. And if you look at the execution metrics for this, we have an execution time. So it took less time if you look at the other one, but the other was a different use case. It was more of a creating content kind of a thing, from data collector to content creation or optimizer. You can look at the total tokens, success rate, agents used, so on and so forth. And you can find out the results over here. Finally, you can see the executive summary. That is what I was saying, right? The summary part of it. You can find the summary, then you can find the map result. Summarizer 1, you find the summarizer 2. If you look at the each summarizer maps that we have here, the chunk IDs, the result, metrics, and find entire information over here, guys, right? It's so intuitive, right, to learn this way, to kind of learn the theory behind it, do it, play with this, and then you can implement it. So this is on the map reduce orchestration. If you look at here, break large tasks into independent chunks, process them in parallel, and then combine results. Excellent for scalable processing of large data sets. So pros and cons will come again. because that we want to discuss, right? Anyway. So I think pros, we can talk in green color actually. So let's come back here and talk about the pros. So we have pros here. Now in the pros, we're gonna talk, say it's for good for large, large scale data sets when you have, that's when it works good. Large scale data sets. That's the time it works, and it's for computationally intensive tasks because it's a computationally intensive tasks. Then it works really good. But the problem is there's a cons also, right? Because there's always a pros and cons. Now, if you look at the cons, it requires a carefully, like you have to carefully design the task decomposition. The task decomposition strategy is key actually. So requires task decomposition strategy, and that doesn't suit all the use cases strategy, right? Because if you're not independent, then it becomes a problem. So keep this in mind. Now consensus mode is the next one. So if you come here on the next one, you will read about it. So the next is consensus mode. Okay, so if you come here on the consensus mode, we're going to go on the consensus orchestration. Now if you look at the consensus orchestration, it says redundant verification. So multiple agents independently solve, like how autogen used to do, right? Autogen had this agents dialogue, right? They kind of dialogue with each other or debate with each other, and they kind of find the best solution for with the voting and all. So this is how it works. So let's say there is a use case of sentiment analysis to find out sentiment. So you can see multiple sentiment analyzers voting on final sentiment. So this is how it works actually. So I'll just go on the consensus now. Okay, let me just come on consensus quickly. Yes, I will come to, okay, let's run the consensus, but then come here. So consensus mode is also good, but the problem is of bias, guys, right? Consensus orchestration, so redundant verification or improves, basically it improves reliability a bit. That's what I can say. But I don't see this as a big, I don't see this as a big orchestration design pattern. Like in my view, I'm not a big fan of this anyway. I'll tell you why. Let's say we have an input task, and in the input task we have an orchestrator here. So I'm just writing org. So we have an orchestrator, and then we'll have different agents. So let's say we have an A1, we have an A2. By the way, I think I missed something here. So let's say if you have A1, A2, A3 MapReduce, you can have the same agent actually, because it's a summarization task. So the agent will remain same, but then they will take the independent chunks actually. So there can be the same agent. So that was a mistake actually. But you can also have different agents. Nothing is kind of stopping you to have, but you don't probably need that, I believe. So let's say you have an agent A1, A2, and A3. I just remember that I was making some mistakes. So you have an input task, you have an orchestration, you have different agents, and then here the voting thing will happen, like consensus we say, right? Voting. So this is the voting consensus mechanism. So this is like voting mechanism. So I'm just writing voting mechanism, and then the majority vote. So let's say there is a majority vote, and then in the majority vote, you get the final result. That's what it is, guys, right? Amazing. So this is a good concept actually. So the key here to ensure that the agents participating in the consensus, are like, and they're also very diverse, right? To avoid the amplification, of biases, because there's a lot of biases here. It becomes a bit, subjective, just like how humans do, right? Where they kind of have to vote based on their own kind of likes and dislikes and so on and so forth. But AI cannot do that, right? So that's why I'm not a huge fan of this, to be honest. But yeah, that's the thing. If you look at the execution metrics, we completed it. There are, let's say, there are financial advisor, there are risk manager, there is a market analyst, and there is operations expert. You can see they have their own opinion. I just said, right, that they become biased also this way. Strongly recommend, recommend, strongly recommend, strongly recommend, and you get a detailed result as strongly recommend, right? Because that's the output that everybody is saying. So this is how it basically works actually for agents. This is on the consensus one. And hierarchical is, if you look at hierarchical, right? Hierarchical you would have worked already. I think hierarchical is also very common with crew AI and whatnot. They kind of provide hierarchical and sequential and all those things, in the hierarchical. So you can see hierarchical is happening here, orchestrator analyzing and decomposing tasks. And code is here. I'm not going that deep dive in code. If you go through the code, you'll understand. Very modular. I have written this code. I took some help of course, vibe coding of doing this, but I gave them the logic and validated it that it's the right thing actually. So if I come here, of course, this is going to take some time. So hierarchical is like it's like a layered orchestration model. It's like specialized division. You have division hierarchy in the organizations, right? Of labor system. That's how I say it. It's a glorified or corporate. Okay. So if you write hierarchical here, okay, let me see the spelling of hierarchical. My English is a bit bad. Okay, so I'm just writing here hierarchical orchestration. I can of course not speak English like most of the Americans and people from the West they do. Hierarchical orchestration. Uh, so it's like, as you can see, right, specialized division of labor. So master orchestrator decomposes complex tasks and coordinates specialized agents. This is also a very good technique. There's a very good design pattern, behind orchestration. But the latency is the big issue. It took a lot of time actually. You can see execution time 52 seconds, almost a minute. Takes more tokens, and of course there are agents. You can see completed, blah blah blah. So it gives you a final result. This is the our use case for the travel actually here. Now how this works actually, I'll write it here for you to understand. So let's say there's an input task, there's an input or a trigger. Let's say the input and a trigger. Now this input and a trigger, okay, I have to bring that screen. Now input and trigger, then you'll have a manager agent. Just like how you have a manager in your team, right? If you're working in a corporate or an IT industry, you'll have a manager who will give you tasks, ask you to update Jira and all, and I don't like it at all. Okay, it's a waste of time. If you look at manager agent, you will have your worker agent here. Okay, so like labor. Okay, so you have your worker A, you'll have worker B, worker C. Most of the managers now that you see in IT guys, they have very limited capabilities. They become manager because they are there for many years, right, in the industry. And of course, that's fair for them, but they have limited capabilities of how, the things are moving nowadays. And that's why they are getting laid off also at the large number. Now, if you look at here, we have a manager agent. And if you're a manager, don't now scold me in the comment box. This is a manager agent. Now there will be a final output. So this will be a final output. This is how it works actually, right? So it's like when let's say you have a travel plan or you have something, right? You can uh, give a smaller tasks, like somebody will look at the hotel, somebody will look at the destination, like some itineraries to visit and stuff, something to explore, restaurant to eat and all, and you can do it. Now the challenges is there's a big challenge. Okay, I'll tell you the cons here. The cons is major here. The biggest cons here is the latency. So if you are not worried about latency, you can look at that, and token cost, which is of course it goes highs, and that will have infra as well, GPU cost if you are on open source. Latency, token cost. The other is fault propagation. Fault propagation is also a very big cons of this, because the challenges of the model lie in the complexity of the orchestration logic and the control because of the fault propagation. So this is a big issue, right? Now for optimization, this is very good because they will have their own specialized domain, because you will give them their specialized domain and the manager will validate that. So this is on the hierarchical orchestration that you see. And here you can find out curated activities, hotels, accommodations are given, find about somebody else. You can see the flight specialist who will find the flights. There are accommodation experts, there are activity coordinators, there are culinary guides, and so on and so forth. So this is how it is, right? Fantastic. So this is the fourth one. Now we have producer reviewer also, which is like producer creates content and reviewer like provides feedback, and the cycle continues until quality standards are met. Autogen was kind of built on this, when it was launched by Microsoft, in the initial time, right? So it's a loop kind of a cycle. So I'll just show you quickly here how it works. Okay, let me just run this. Let's say we have a legal thing, that is fine. Just run something here quickly. Now here I'll show you, and then we wrap this up. Now the next design pattern for the orchestration is producer reviewer, right? So here we are writing producer and reviewer. Producer and reviewer. A simplest thing, okay, not a lot of complex. Let's say there's a decision that somebody has to take. So here I'm just writing decision. Of course, agent has to take. Now decision. Let's say if this is yes, and then we'll have a final output immediately. Simple funda, right? If decision, then yes. And if there's no, no is the yes or no. When there's a no, then here we have, of course, we'll have multiple agents. Like let's say there are agents. So I have agent B, I have agent A, I have agent C, right? Now these all are connected with each other. And then there will be an input trigger here. If this become an input or a trigger, input trigger. And now these input trigger goes here that you see. And then here we have check, like it passes the check or not, because let's say the last agent that we have is the check and validate agent. This is our check and validate. This is our plan and execute. And agent C is like correct and debug. Correct and debug. So this is how the workflow is. So this is like a producer reviewer. So here we have taken a legal document summarizer use case that you see. The latency is very less for this particular thing, and quality score improves over a period of time, right? That's the iteration. For this, you can see there is you can find out here because there's some information that we have in the backend. You can see the software license thing. You have final review. It says needs revision. It gives you a score and gives you a feedback. The summary provides a good overview of the software license agreement, but lacks some key details and clarity in certain areas, right? This is what it does. There are two agents which are used, producer, reviewer that we have. So keep that in mind. The design of the number of iterations and exit conditions directly affects the balance between system efficiency and the final quality. That's you have to keep in mind. So these are the five that I wanted to show, right? We have seen for producer reviewer, we have seen hierarchical orchestration, we have seen consensus mode, we have seen MapReduce, and we have seen sequential orchestration. I'll keep my Mac aside for a little bit, to tell you a few things, right? Now, these are good, very good thing, guys, because when you are building agents, you can also make it hybrid. Let's say your use case is very complex, where you might have to combine these orchestration patterns that you have, right? You might have to combine, let's say you have a use case where you have a lot of documents. You want to do RAG, so you'll do summarization also, and then you have to fetch some information, and then you'll have to create some content. So you can combine sequential with MapReduce. So you can build your custom orchestration patterns also. You don't have to rely on like whatever the framework is providing. You can always create base. You can do it through base classes, right? You can extend that. So this is what I wanted to show you in this video, multi-agent orchestration playground. If you want more frameworks and methodologies like this, you can get Agentic AI Toolkit. I'll give the link in description. Now, Agentic AI Toolkit is a 5-in-1 bundle kit that gives you end-to-end workflows. It gives you 3 months of learning roadmap that will help you learn AI agent faster. You'll get different frameworks like success framework, use cases kit, governance kit, so on and so forth. So you get this also. I'll give the link in description, and I will give this chart probably if you need that, right? Now, this is very important for you to learn all of these skills. Don't only rely on building some LangChain POCs by watching some videos by people who are creating it. It will not help you in the longer run, because you will not be required to build LangChain POCs. They can easily do it, all these vibe coding IDEs, right? You need to go deeper understanding of system designs, the data structures. And when I say data structure, it's not that data structure that you do with Java and all this stuff. I'm saying AI data structures. You have with tensors, you have with numpys, the way you create vectors. There are a lot of data structures involved in that, right? So keep that in mind. And if you are a leader or somebody who is building a startup, okay, first upskill yourself, and this is important. Okay, so keep this in mind. Don't rely on vibe coding tools. That will take you nowhere, actually, guys. Anyway, that's all for this video. If you learned something, if you like it, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos, right? Share this video and channel to your friends and to peer. If you have any question, thoughts, or feedbacks, let me know in the comment box. That's all for this video. Thank you so much for watching. See you in the next one.